Right, in 4.1, we are graphing systems of equations. So, some key terms. A system of equations is two or more functions with the same set of variables. A solution to a system of equations is the same set of answers that work for all functions. For example, if we were given 2x minus 3y equals 8 and 4x minus 6y equals 16, 1, negative 2 is a solution since it works for both functions. And I'm not going to do the work for this. You'll see some examples on the next slide. A solution on a graph is anywhere the functions cross. Therefore, there may be more than one solution to a system. So before we start graphing, first we're just going to check, is an ordered pair a solution to a system? To do that, you want to make sure that you can keep track of your x and your y. Whenever we plug in an x and a y, we want to use parentheses. So I'm going to take and replace my x in this first equation with 3 squared plus my y is 0, and we want to square that, equals 9. So I took out my x and y and I replaced them with those coordinates. And I'll do the same with my other equation. Y is 0, x is 3, minus 5. And then we can go through and see what we get for the, see if these equations are true. So 3 squared is 9, plus 0 squared is 0 equals 9. 9 equals 9, check. So 3, 0 is a solution for this, for that first equation. Now for our other one, 0 equals 3 minus 5 is negative 2. That's not true. So 3, 0 is not a solution. And that's because it didn't make both equations true. The left side didn't equal the right side for both of our equations. So try B. All right. Negative, or whoops, 2, and that's not negative, it's a positive 2, equals 2. We take out y and put negative 3 in its place. And I do the same with my other equation. 2, x is 2, plus y is negative 3 equals 1. So 2 equals 2 times negative 3 is negative 6, plus 8. 2 equals negative 6 plus 8 is 2. Check, that one is true. 2 times 2 is 4, plus negative 3 really means minus 3 equals 1. 4 minus 3 is 1 equals 1. Check. 2, negative 3 made both equations true, so that means 2, negative 3 is a solution. All right, now we're going to look at seeing our solutions on our graph. So our solutions are where our graphs intersect. So that first point in quadrant 1 is at 2, 4, and our other point in quadrant 2 is at negative 1, 1. All right, you try. What are the solutions for this graph? So here's one solution and here's another. So one of our solutions, now be careful, pay attention to your graph. That is 1, and it's actually a negative 1. and then 3, then we have 2, 0. All right, the final thing we're going to look at is now graphing to find our solutions. I'm going to show you how to graph using your calculator and using Desmos. So on our calculator, if we want to graph, we want to get to the one that says graph from our main menu. So that's number 5. And then we type in what we're trying to graph. So 3/2. To get your x, you want to press the button below alpha plus 1. Then my other is negative x plus 6. And then to graph it, I'm going to press execute, draw. Now I can't really see, so if I want to zoom out, I can press the zoom button and then out. And maybe I move this little arrow. So it zooms out so I can see it a little bit better. Okay, so now I know it's not easy to see where that point is. So we're going to press this G solve button, so F5, and then ISCT means intersection. So that's where our points are crossing. So I'm going to press F5 again, and it tells me that those are crossing at 2, 0. So those would be crossing at, 2, 4. So I graphed them, but I graphed them on my calculator. And I could plot that graph over here, but I'm trying to save time for us in this video. So now, if we have functions like this, where one, we call this y-intercept form, the first one, and then this other one is standard form. You cannot put this second equation into these calculators. So we have 2 options. One, we could solve for y. So then we get y equals negative 3x minus 2. Remember your term with the variable goes first. So now I can go back to my graph. If I want to clear it, okay. So now I can graph this, parentheses x plus 2 squared minus 6. And now I have to make sure I type in the one that has y equals negative 3x minus 2. And then draw. So because we have a parabola, so our graph, this is a rough sketch, this isn't exact, but it looks something roughly like this. These are going to cross at 2 places. So when I press to find my intersection, so that's F5, F5, gives me one at negative 7, 19, and then the other one, if I press the down button, if I press enter again, okay, sorry, it's not the down button, it's the side button. Then it gives me my other point of intersection. So once again, to go back and forth between your intersection points, if you press the side button, and it goes on what side? So if I want to see the point on the left, press the left side, point on the right side. All right. So this one, I want you guys to try graphing this using Desmos. All right, so using Desmos, I'm going to make this a little bit smaller so I can see my problem still. and then I'll make it larger. So I am graphing. If we're using Desmos, you can type it in exactly as is. 2x minus 4y equals 4, and it'll graph that. And then y equals negative the absolute value of x minus 2 plus 3. So now I'm going to make this larger. We can see where our graph's crossing, 4, 1 and negative 4, 3. So the solutions to this one would be 4, 1 and negative 4 was negative 3. And that was solving systems by graphing.